All right. Welcome in, everyone. Happy Wednesday. I am Professor L, and I am again doing a live stream. Just going to work a problem. Hopefully, it'll go pretty fast. And yeah, if somebody has a problem that they want me to try, they can post in the chat. Otherwise, I'm just going to work the problem I picked out. I'm still working with matrices, and I'm practicing solving systems of linear equations with two variables right now. And so, yeah, I'll probably just go ahead and see how fast I can solve one of these today. Honestly, I am running behind, and I did not have a lot of time to spend on math. So this is my, I guess, math moment of the day. This life is so hectic and exhausting, I'll tell you. Evening is not the best time to be doing math, but we'll just make the most of it. It's the time that I've allotted so far, and oh, I wish I wouldn't have erased that. I'll just put the formula back up. So what we're doing is we're solving systems using matrices. And yeah, I just try to calm down and think about letting the math flow out of my mind and see how it goes. And, you know, maybe I'll help somebody in the long run, but who knows? This is still good for me to be doing this, and hopefully I'll be helping students work with matrices. And if you need to know how to solve one, maybe my video will help. Won't be too boring. All right, so I have this system. Let me go ahead and back up real quick. I better just calm down. I'm getting a little ahead of myself here. I want to go ahead and erase the title. Get ahead of myself, and I'm not thinking about what I'm doing. That's not good. So we're going to put systems of linear equations. And then I'll put off to the side matrix solutions. And that is the highest I'll have to write on my board today. All right. So I'm just trying to stay organized in case later on I want to go and catalog these and split them up and get all the fluff out. All right. So we are going to just go through this method once, the method in its entirety, and no warm up and no other problems, just this one for today, and see how this goes. So we have this system. It's 2/3 x minus 1/2 y. And that is going to equal 5. And this one is 5x minus 4y. Oops, smudged. And that is going to equal 34. So we have this solution. And I got this from the chat, the Google chat AI, and it said solve it by, it's giving the elimination method. And it does give me a final intersection solution. Good. So I have the solution. It says it is, we'll put it up here just so I don't lose it. 18 and 24. Let me try to find it again. Okay, 18 and 14. All right. So we have the final product here. We'll write it down here. We have the solution 18, comma 24 is an ordered pair. that appears on the Cartesian coordinate system where your first component is x and your second component is y. And we are going to use this method of finding the inverse where it's, I'm going to try to see if I can write the formula by memorization now, because it's like day 3 working with it, and eventually I want to have this math in my head. So the formula for calculating A inverse is 1 over the determinant of A times the matrices, and let's see, we swapped out the diagonal, so it's dA, and then we did not swap this diagonal, we just negated it, I think. Now I want to double check and make sure. All right, pretty sure that's what it is. Let me just make sure I don't have it written down. Rookie mistake. Okay. All right, negative B, C, A. Perfect. All right, I just wanted to double check we have it written correctly, and we do. All right, and so then we're taking A, which is a 2 by 2 matrix, and it's going to be A, this is if A, B, C, D. So here's the formula we're using. And this method, what it does is it employs splitting up this, and I think it's called an what you're doing is you're turning it into a matrix. So right now it's just 2 equations, 2 linear functions, but we're going to split it up. And the way that you do that is you first make a matrix of just the coefficients of your variables. So it's called the coefficient matrix, and that's why, because it's just your coefficients. 2/3, 5, -1/2, and -4. So I asked explicitly for a harder example, so we can see how easy it is to do this. And so now we're going to multiply that by your variables. So we'll say x, comma, y. And then that's going to equal the matrix, your constants. Okay. So that's 5 and 34. It's not a fraction. Okay, perfect. So now what we have to do is, this is like the equation. Well, to solve this using matrices, essentially saying this, x, comma, y equals, so it's your inverse matrix. So we'll go ahead and list it again. 2/3, 5, -1/2, and -4. And this is raised to the -1. That is notation for inverses. And then that is multiplied by your constants. So essentially, you're finding your inverse, multiplying it by the constants, and returning the solution. Okay, so that's what we're going to do. So we're first going to take this matrix right here, and if you want to, you could just plug them in and switch them. What they're doing is you're switching out, you're swapping. You wouldn't even have to make a list. So we're swapping out this diagonal. So right solution here. So we're first going to use this formula to swap out our diagonal. So we could just do it pretty quickly. -4 and 2/3. And then rather than swapping this diagonal, this one's not getting swapped, it's getting negated. So this becomes a -5 and a +1/2. And then we have to calculate the determinant. The determinant of A. And you do that by, it equals A times D minus B times C. So A is 2/3. D was -4. And B is -1/2. I would watch that right there, because if your value is negative, you're going to have an extra one, and that's a place where you could kind of mess up. Easy to do. And then the original C was +5. All right, so we'll figure out this using order of operations. This is 2/3 times -4, so that's 2 times -4/3 minus -1/2. We'll just say -1 times 5/2. It's a kind of a simple way of combining, multiplying. So you've got -8/3 minus -5/2. All right, so that becomes -8/3 plus 5/2. All right, so that is going to be 6 will be our common denominator. 8 times 2 is -16. And 2 times 3 is 6. So 5 times 3 is 15. All right. So it looks like the determinant, if I did my math correctly, my calculations, -16 plus 15 is a -1/6. So we'll say -1/6 and circle that, because that's what we have to. Ooh, it's 1 over the determinant. Interesting. All right, so we'll have to calculate 1 over the determinant equals 1 over -1/6. 1 over -1/6. So when you are dividing fractions, you take that second term and you invert and multiply. So that becomes 1 over 1 times -6/1. So that is -6. So 1 over the determinant is -6. That means that for this formula, we need to multiply this matrices by this scalar 6. So we'll have a new matrix that should be the inverse, honestly. So we've got -6 times -4 is +24, and -6 times 1/2 is -3. And -6 times -5, that is +30. And we've got -6 times 2/3. So that's -12 divided by 3 is -4. Okay. So this should be our inverse, A inverse. So according to this, all we have to do is multiply it by the constant matrix, and we'll have our solution. So we'll put that right here. 5, 34. Hopefully I did my math correctly. And remember, it's A2 by 2 times A2 by 1. So you're going to get a 2 by 1 as a result of your matrix, and you can multiply. What you're doing is you're taking your rows times your columns. So we've got 24 times 5. So we'll do this row 1, column 1 is 24 times 5 minus 3 times 34. $30, $60, $90, and 4 times 3 is 12. That's 102. I like to do it in my head and then do it. And then this is 96 because it's almost 25. Or wait, no, that's 120. 24 times 5. But then I always just make sure. So we've got 120 minus 102, I believe. 34 times 4, or 3 rather, is, yeah, 110. All right, so we've got that 20, that's 18. Perfect, which we already knew that. And then we'll go ahead and sneak row 2, column 1. Row 2, column 1 is row 2, column 1. So it's going to be 30 times 5, which is 150. And then 4 times 34. We'll just do it. Such an odd number, 136. And 1 equals 4. Wait, it's not 24, it's 14. I don't know why I know I said 14, it scared me. All right, so this is 14, perfect. 50 minus 136. All right, so we did it. Or I guess I did it rather, in, looks like only about 15 minutes, which is fine. I'm exhausted, and so that's fine. I really wanted to do the live stream, even though I wasn't feeling it, and I just honestly, up until the last minute, didn't know if I was going to do it or not, but I did, and it is what it is. I'm glad. This is how to solve systems of linear equations in 2 variables. So using matrices is another way to do it. Again, if you watch my video, thank you so much for watching. It's a way of supporting me by just watching. I mean, that's awesome because it makes me feel like I'm not alone doing math, which is great. Today's a perfect day to do some math, in my opinion, and I'm glad that I got some done. And yeah, so it is taking a lot of discipline to get up here once a day and do it. But again, it is what it is. So I will sign off for now and say goodbye for now. I will see you next time, tomorrow, hopefully. Bye.